Hey everyone, welcome to the Fairblock and Arbitrum Stylus integration quick start. My name is Hash Titan. Y'all can call me Hash. I'm a DevRel contributing to the project. And we're going to go over the tutorial today, as well as touch on key points about Fairblock and Arbitrum Stylus. And just so you know, this tutorial was actually ran at DevCon 2024. And yeah, let's get into it. So just to help you decide if you want to continue with this video or not. Essentially, this video is going to be around 20 to 30 minutes, depending on how quickly I run through the code. And it will basically be revolving around a simple sealed bid auction example deployed using Solidity onto the Arbitrum Sepolia test network. And the Arbitrum Sepolia test network is integrating Stylus, which we are using today to deploy a Fairblock decryption contract or set of contracts such that the sealed bid auction example can actually integrate with the decryption contracts and carry out conditional decryption essentially and show some of the functionalities of Fairblock. So with that all said, we'll start with going over just a general high-level touch on what is Fairblock, what are dynamic confidentiality networks and Fairyring V1, the relationship between Fairblock and Stylus, and then move on to the actual transaction flow of the V1 architecture, as well as what the underlying components within the deployments of today's tutorials are. So the decryption contracts with Stylus, and the integration contracts. So the validity contracts actually testing the full functionality of the decryption contracts that were deployed using Stylus on the Sepolia network. Next, we'll go through a full code walkthrough, or at least touching on the key points so that you have some like hand holding as you go through it yourself. And then after that, we'll talk about the next steps that you can take if you're a developer or that wants to integrate with Fairblock, or if you're someone who wants to contribute to the ecosystem. And finally, we'll conclude from there. So before we get into what is Fairblock, let's touch a little bit on the current blockchain ecosystem at play. In today's world, we have a lot of fun and exciting meme coins, don't get me wrong, and a lot of sick infrastructure. But one fact still remains, and that is that the amount of apps out there and thus the user base using these like more innovative, interesting apps is pretty mid. And we could have a conversation about that for days, probably, of why. But one challenge remains consistent and present, which is that there's a lot of intermediaries, bots, bad actors due to data leakage within these blockchain spaces. And apps that we hoped that would have been carried out and done today still are having trouble because of this challenge. Those include, but aren't limited to, voting, sealed bid auctions, and DeFi with MEV protection. So then the question then becomes like, okay, well, where does Fairblock fit into this? Well, that's what's exciting about this Anon. So basically, Fairblock is a decentralized network that helps solve this by enabling apps to process and execute encrypted transactions. There's multiple points on this, but three that I'd like to highlight. One, Fairblock enables safer and more capital efficient experiences for users. And it's easier to illustrate that with an example. So let's take like a Uniswap transaction. Usually, it's just hit with MEV, and that's just the way it operates. There's some different solutions out there to try to circumvent that a bit more. But imagine actually the transaction details actually being fully encrypted and sitting in the mempool awaiting certain conditions to be hit or to be decrypted and executed instantaneously. Some of those conditions could be, say, price swaps or what have you. This little process or this whole process would then circumvent MEV. We can expand that even more to like just different examples, like completely different use cases, such as games or like a simple game like poker. You could have the game logic be respected, and using, conditional decryption, you could have the respective conditions set such that maybe once a round is over, the player's hands are exposed, etc. And so it really unlocks, you can start to see more unlocks start to happen for different apps on blockchains as Fairblock is integrated. And then with number two here, dynamic confidentiality network offering app bespoke solutions. That's what Fairblock is and does. On that point, basically, you can have not just like one MPC scheme, but you can have just a whole suite of MPC schemes. So you could have TIBE, FHE. Essentially, you could have solutions where you might have, say, the sealed bit auctions that we're going to go through today, and it uses TIBE, conditional decryption. It's great. Or you could then have a completely different app that might want encrypted computation done in a compliant way with regulatory bodies in its respective niche. And then moving on top of that, Fairblock can be integrated into any chain. So we're talking EVMs, whether it be using Stylus as shown today, or Orbit chains, or whatever, or even Cosmos chains, as Fairblock itself is a network too. And just on that note, like basically integrations are being actively worked on within the Fairblock community. So that hopefully just gives a rundown of, hey, like a lot of different applications can be created and the sandbox is bigger and bigger and bigger. It's just a wide space, really, which is really exciting for what Fairblock helps unlock. For today's tutorial, we'll be talking about the V1 of Fairblock. So that's Fairyring right now. That's the network and that's its name. It's currently in testnet, and it'll be the underlying architecture that is used for today's tutorial. So it's good, I think, to actually jump into the architecture and understanding the transaction flow involved. So a quick thought on Fairyring. So as mentioned, Fairyring is the test network. It's active at the moment, and it uses bespoke TIBE or threshold identity-based encryption. And essentially, it does a multitude of things, but two main components is one, it exports dynamic confidentiality computation. And within that sentence, that's basically revolving around two components, which is it pushes out public keys and pushes out decryption keys for encryption and decryption respectively when working with a different destination chain or app. And then the second thing that it can do is actually host said apps, because since it is a blockchain itself, it can host apps that are truly leveraging and enabled by confidentiality solutions. So with that understanding of V1 Fairyring at a high level and what it offers, in today's tutorial, we're going to be focusing more so on number one. So the use of the public keys, the decryption keys, and using Fairyring as like the source for these tools, as well as paired with all the other technologies within the Fairblock suite. And so it's good now to jump into the user flow or the transaction flow that is typical, and that will be underneath even this sealed bit auction example tutorial. A big thing to touch on though, before we go through the user flow, right, is just the high level components. So what I'm talking about are four main components, and actually one of them is not even fully labeled here, but it's there and we'll get into it. Essentially, you have one, the example chain. So this whole range here, otherwise referred to as the destination chain within our documentation and literature. And so this is where the encrypted transaction will live. This is where the execution occurs, right? And it then communicates with Fairyring. So Fairyring is our test network, and you can treat it as just a general network that will provide the publication keys for encryption and the decryption keys for decryption. And then the third thing that I mentioned that isn't here, or you can't see it fully labeled, is Fairyport. So it's our software that acts as a relayer, so anyone can run it and basically then obtain the public keys as well as decryption keys from Fairyring, and it relays it back to the destination chain. So it actively communicates between the destination chain and Fairyring in accordance to whatever conditions it's trying to look for. It's reading for a certain event emission, etc. We'll get to it. And then fourth is the Fairblock encryption SDK. This is more so for the front end side of things. Underlying it is the encrypted tool, which can be used for people who want to just work with it from the command line or what have you within their like troubleshooting and back end side of things. But the encryption SDK allows for front end developers to basically incorporate the appropriate encryption methodologies when working with Fairblock. So that way, is a nice segue into now the transaction flow. When the user submits their transaction, that it actually will encrypt it accordingly and have it work and function with everything else involved with the Fairyring Fairblock process. So when it comes to like looking at the actual transaction flow, I like to clump it into two clumps. So clump one is 1, 2, and 3, and then clump 2 is 4, 5, 6, 7. So within clump 1, you basically all these happen like sequentially, but essentially within the same transaction flow. The user will come along and submit an encrypted transaction with designated decryption conditions. What this is really referring to is that, just quick context, is that traditionally IBE, right, or identity-based encryption revolves around personal identification. But in terms of Fairblock's setup and context, Fairblock focuses more so on different markers and conditions as the actual like IDs or markers, right? So IDs aren't referring to personal identification. IDs are referring to just IDs that are associated to the respective specific encrypted transaction. Now that means like you can have encrypted transaction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and they can all have the same ID. And what that means is that they're basically using the same, public key and will use the same decryption key for decryption accordingly. And by default, the actual setup right now is that Fairyring will use the block height of whatever block we're focused on within Fairyring, and produce the public key and produce the decryption key for that respectively when requested. And that is used to actually encrypt the transaction coming in from the user. Again, this is all behind the scenes, but I'm mentioning it because, the phrasing might be confusing here of like, how is it encrypted? What's going on? And so when the user actually submits a transaction, right, by default, we use the block height of Fairyring, but honestly, it could be swap price. It could be anything that could be used as the identifier, ID, that will be used for encrypting the transaction. So then we have step one, right? And as I just kind of like alluded to with that longer context on how ID is associated to encryption, essentially what is happening when the user submits a transaction is that the front end will then communicate using the SDK, using Fairyport with Fairyring. If it doesn't already have a public key, get that public key associated to the respective ID, which could be anything. And then from there, actually encrypts the transaction. The encrypted transaction is then submitted, events are emitted, and Fairyring will pick that up via Fairyport. And finally, the encrypted transaction will then be stored in the mempool of the respective chain. So I know that was a lot, but basically, yes, encrypted transaction is taken in with the, its and its sensitive data is more so the transaction details submitted by the user. It has an ID associated to it that'll be used later on, as alluded to, for decryption, and it was definitely used for encryption. And then finally, it's stored in the mempool. Now, clump 2 is like, okay, cool, we're all good. We have the encrypted transaction living in the mempool. Next, we wait for some condition. Let's say we're using the sealed bid option example for this, right? So the encrypted transaction sets of data is probably like the bid price that is being submitted. The next step, right, that we're waiting for is a certain block height to be hit. So let's say the auction ends, a certain block height is hit, great. That will then cause an event to be emitted within the destination chain, such that the Fairyport will then say, hey, an event has been emitted requesting a decryption key with this respective ID. Great. Let's take that ID and send it via Fairyport to ask for a new key to be generated, like a decryption key for it to be generated from the Fairyring validators. Now, this is where the threshold side comes into play. So basically, in a very quick nutshell, the validators each piece by piece generate a piece of the actual decryption key using that software. And from there, right, once it's all agreed upon, then a certain threshold of that decryption key is generated, and then the rest is extrapolated and further derived so that it can then be pushed forward along Fairyring, thus threshold IBE. So then it's pushed to the actual destination chain, and boom, transaction is decrypted, and then really it's up to the application that is working with the decrypted sensitive data to actually do whatever it needs to do and then execute it. Cool. So that is a lot, I understand. But basically, this transaction flow, right? Let's do a high level overview again. The user submits a transaction, it gets encrypted using like IDs from using public keys that are derived from IDs from Fairyring. And then from there, it's stored inside of the destination chain. And then finally, once a state change occurs that triggers the event emission to actually cause a decryption to occur, then boom, a decryption key is generated from the Fairyring validators and then submitted such that the destination chain receives it and then can actually decrypt the respective transaction and do whatever the heck it needs to do with it and execute it. And to note here, the tutorial today will be just focusing mainly on the Rust deployments of the actual decryption contracts with Stylus onto the Sepolia network, and then also the testing of that using the integration contracts. So when it comes to the listening to event emission and all that with Fairyport, or the actual generation of the keys of Fairyring, we're not going to be focusing on that today. Okay, cool. So now that we understand that, just a quick little primer on Fairblock and Arbitrum Stylus. So essentially, if you don't know, Arbitrum Stylus is a growing developer tool. It's great. It basically enables developers to deploy contracts using WebAssembly or WASM. And this means languages such as C, C++, or Rust can be used to deploy smart contracts onto a network that integrates Stylus. So in this case, again, it's a Sepolia test network. And you can learn more about Stylus here. You can be able to find the slides after. And basically for us, with Fairblock, Fairblock is deploying the decryption Rust contracts onto the Sepolia test network using Stylus. And that way different smart contracts can actually interact with it as if it was written with Solidity, for example. Whew. Okay. So I swear we're almost getting to the code, but take a pause this whenever you want. Touch grass, sip some coffee, whatever. We'll get through this together. And if you're ready to keep going, then let's keep going. So essentially, before jumping into the actual code, it's good to get like the lay of the land. If you're a big fan of Zelda like I am, you wouldn't jump into a dungeon without a map, or else you might just have a bad time. You probably get through it, but let's just touch on the dungeon map a bit. So essentially, I wanted to talk about the decryptor contracts that are being deployed using Stylus. So really, they are five components that make up, or basically they're five smart contracts that make up the decryptor contract as a whole. So essentially, these individual smart contracts are deployed in this sequence. And to me, again, I like to clump things into some working order. So to me, it's like these two contracts work together and Cha-Cha works together as well. And the decryptor contract is an interface that any contract basically ends up working with. So you'll see with our sealed bit auction smart contract, it actually interacts with the decryptor contract, which thus then triggers all these underlying contracts to carry out verification and decryption. And a fun note as well is that, okay, well, why are there these four extra components? Like, what are they doing? Well, at a high level, essentially, there's two layers of encryption. One is using IBE encryption, and then the other one is using symmetric encryption. And so with the IBE contracts, what's happening besides verification, et cetera, is that the actual like symmetric key that's ending up being used in this encryption layer is being decrypted, which is great using IBE. And once that's obtained, then the symmetric key is then used in symmetry encryption or symmetric encryption to actually obtain the plain text. And the plain text is the sensitive material. So it's like a transaction detail for, say, that Uniswap trade or the bit amount. That's what we're getting. So with that, IBE, Cha-Cha, they are the underlying constituents for the decryptor contract itself. And the decryptor contract is where we're interacting with when we are actually trying to call out and use and push forward with like a decryption transaction flow using Fairblock tech. And now that we understand the decryption side or the contracts at a high level, right, which I'll showcase in the repo right away, then we get into the integration contracts. So honestly, these are just simple subdirectories you'll see in the repo that consist of like just bash scripts as well as the smart contracts to carry out certain testing and interactions with the newly deployed decryption contracts that we just touched on using Stylus. So you'll see a Rust implementation showcasing, a Rust contract can actually work with this and interact with this newly deployed decryption contract. Or we have the equivalent version in Solidity. So these are A and B are both Hello World implementations. And then C is what we'll really be touching on today, which is the simple sealed bid auction example written in Solidity, where bids are encrypted and conditionally decrypted and then once the auction is over, that's when the decryption occurs. Yo, we made it. So let's jump into code and have a great time and go from there. So here you can actually see the Arbitrum contracts repo. And from this, you can actually see the subdirectories. So there's a full-on README in here, and essentially it'll highlight like these two main scripts that you can run from the root once you actually clone the repo. But essentially, what's happening, as mentioned when I went over the high-level overview, so it'll be nice to actually look at the repo now too, is that you can see like Cha-Cha 20, IBE, and the Decrypter contract. These are where the Rust implementations are living. And we won't go into the actual like details of the Rust code, but you can scope it out for yourself when you check out lib.rs in the respective subdirectory. And then from there, though, you can see at the root, there's test contract Rust, test contract Solidity, test simple auction Solidity. Let's go to that one. All of them have this similar setup. And they have their own individual readmes. Essentially, what it's telling you is that, hey, if you want, you can come into like CD from the command line and what have you into this actual subdirectory and run this bash script if you'd like to actually test the functionality of just this one individual respective like smart contract. Here's the simple bid auction smart contract. We'll showcase it in my actual like VS Code. But yes, essentially this script here and this layout is standard for these integration subdirectories. If you want to test like different implementations, if you want to clone this and start setting up your own repo such that you can actually test with like, the decryption contract and using like bash scripts to do so. Whether you're writing with Rust, Solidity, etc. So, and then furthermore, we have like actual deploy decryption contracts like scripts. So as I mentioned before, all you will be really doing is running like .build.sh or .stylus /stylus tutorial.sh. And that was just done so that we could actually, if you jump to the code side, if you skipped all my preamble, skipped all the context, and just jump straight into the code, you could actually then run this tutorial in less than 5 minutes by running those two scripts. So we'll jump into it again and talk more as I look at the VS Code. But essentially, what you're doing is one, the build.sh is running everything necessary to set up the repo and the dependencies. Note that you need Docker running as well, Docker desktop. And then two, the actual stylus tutorial. Oh, go back to this. So with the stylus tutorial.sh, as you can see here, it's actually just going through and eventually running the deploy decryption contracts verbose. Verbose means just like the actual like echoing and logging of everything that's happening. You can really check out all the details versus other scripts. And yeah, it'll also prompt you accordingly for your respective private keys to fill into the .env file accordingly for yourself, and also to copy over the decryptor contract, because that's the first stage of everything. Once you deploy the decryptor contract onto the network, so the Sepolia network here, then it's going to ask you to like update your env file with the new decryptor, and from there you'll actually be then able to run just continue with this script, and it'll actually run the ./test.sh file that I kind of pointed out that exists inside of each of the respective testing subdirectories. So you'll be running this code here, which then is like actually running checks against the sealed bid auction example and using decryption in its full reality. So with that, let's jump into VS Code. All right, Now that we're into the actual code, this has just been cloned onto my local machine. And I've gone ahead for the sake of time to actually run the two scripts. So the both bash scripts, the build script, as well as the stylus tutorial script. And we'll go through some of the code before actually looking at the output results. So as mentioned, the build script is simply just setting up the project. So it's installing the submodules and building them, it's installing Rust and installing Stylus and installing Foundry. So here in the terminal down here, you'll see like that output respectively showing all the different things installed, such as Foundry. Cool. And then if we move along, so the next step would be to make sure that your env file is actually populated accordingly. So you're going to need to populate it with two different private keys, so corresponding to different wallets, of course. And in each of them, I think for private key one, you'll need about 0.8 ETH in Sepolia ETH. If you have any issues grabbing that, then just let us know and we'll hook you up with the appropriate faucets and do what we can. In the future, we'll tweak it so that it doesn't require that much ETH, Sepolia test ETH. But for now, that's just needed to actually deploy Decrypter contracts. That said, if you want, you can just use our in the actual tutorial, we'll put down like an actual deployed Decrypter contract address in case you just don't want to go through that step. And then that way you can kind of bypass that, not need to Sepolia ETH and actually just test your own contracts or test this sealed bit auction tutorial or any of these integration tests with it. So for the RPC URL, just leave that as is since we're dealing with the Sepolia rollup with Arbitrum, and then the deployed decryptor address, as I just said, we'll need to populate that. And if you go through this tutorial from start to finish, then you'll end up actually populating this by running the next script. So at this point, you need to make sure that Docker is running, of course, because in here, we're going to be needing it. So within the Stylus tutorial bash script, what it's doing is two main things. As mentioned, caveat or a slight aside is like, yes, it's going to ask, hey, did you actually populate two private keys for Sepolia wallets, as mentioned in your own env file. So you'll hit enter as you go through it. And then it's going to run the deploy decryption contracts for both bash script, which we'll take a look at quickly here. And so here, this one is actually deploying, the 5 smart contracts that act as the components for the overall decryptor contract. So IB hashing, IB contract, SHA-20 MAC, SHA-20 decryptor, and then finally the decryptor contract itself. And it echoes out the result. So if you look at down here, I've already ran it as mentioned. So you can just scroll up a bit because this is the other part of the script that we'll cover in a second. Here we go. So here are some of the outputs. It's just more above, but I don't need to show them really right now. But essentially, you'll get the different addresses that are deployed on the Sepolia network, which is great. And then you'll take this decryptor address and then end up actually populating it here, as mentioned before. Yeah, so then from there, the Stylus tutorial has finished deploying the decryption contracts. It asks you for the decryptor address. There you go. And then it moves into the subdirectory of the simple auction and carries out the actual test file in there. So this is a good point to actually jump into the sealed bid auction example and the actual Solidity file. So within the actual Solidity file, you can see that this is just purely, again, for educational purposes. This is not production ready code. None of this is production ready code. And just obviously take that and go through the due diligence that you need to go through when creating and deploying your own smart contracts as well as applications. But essentially, the sealed bid auction example is covering a design where bids are encrypted and submitted and then revealed using the decryption key once a certain time has passed. The bids are in structs and the real juice, aka the ciphertext, or aka the encrypted transaction details are right here per bid entry. So for a sealed bid auction, that's going to be your actual bid amount. And then everything else here in terms of the variables, like the bids ones is important because it's just the array that gets populated as we submit more and more bids. But everything else, like, is just details for the auction contract, so it doesn't need to be really emphasized during this tutorial. One thing to emphasize is that here it's a good example of like, okay, you're making a smart contract that is now interacting with the Decrypter contract on a Stylus integrated network. So if you're doing so, one way to do it, just like working with any other interface, is to simply outline it inside the constructor. This is really a design choice, but this is just showing how we're going about it in this simple example. So it's deployed as an immutable, or it's set up as an immutable variable, right? But in future reference, that there might be a need to actually have different decryptor contracts on different networks, or have to upgrade them for some reason. Obviously, that probably won't be the preferred case, but things happen. And then moving along, we have our main two functions, so submit encrypted bid and reveal bid. And this third one here, issue refunds, is more so for the auction details. It's like a little extra aside. But for these first two, submit encrypted bid, it is populating the respective bid with the encrypted bid as well as all the other details associated to it. And it's obviously checking, hey, is the block timestamp pass like the bid condition, aka when the auction deadline has passed? And then reveal bids, it does the check of, hey, is the auction still going? If it isn't, then it can actually, go ahead and reveal them, and it reveals them by calling the decrypted contract and the decrypt function within it. And from there, it actually puts it into a format that is understandable for the smart contract. And the smart contract actually then records like, hey, who's the highest bidder, and then what is the highest bid, and finishes and finalizes the auction. As mentioned, like transferable functions as well as like the refunds and stuff like that. That's kind of like more so smart contract design and other scope. Like we know how transfers work. So it was just left out for this tutorial since the focus is meant more so to show the submission of the encrypted transaction in a smart contract, the typical transaction flow, and the decryption of it and the usage of that decrypted ciphertext. So with all of that said, we can then talk about the actual deploy decryption contract verbose. Or sorry, we talked about that already. I meant the bash test script here. So, because this really just shows like the transaction flow using the sealed bid auction example. And within here, you can see that, we go through the actual deployment of the Solidity contract, and we're doing so using the current Sepolia block number, a deadline block number, and a decryptor address that was deployed from before, referencing the env file. And from there, we then use tools such as the share generator and later on the encryptor. So we use the share generator within this tutorial to create the key share and the public key associated to it, or vice versa, I mean. And one thing to note is, so the public key is used for encryption. The key share is part of the decryption or derivation to get the decryption key itself. And normally this is not how the flow would go. As if you recall from, earlier in this tutorial, the architecture and the transaction flow is mainly revolved around, Fairyring, as well as the use of Fairyport, communicating between the destination and the Fairyring networks. And so the key share and decryption key would be normally generated from Fairyport, relaying the request for these details from Fairyring to deliver to the destination chain. So this tutorial is honestly just like a simplification of this by using these tools so that we can just grab a public key, grab the key share for decryption, and just go along. Later on, we'll have to round out, the integration steps with integrating with Fairyport as well as the Fairyring network, and that'll come at a later date. Cool. So then from there, you can see bid values of 100 and 150. These are two separate bids. The encrypted transaction is prepared using the encryptor tool. And I forgot to mention that the encryptor tool, as well as the share generator, they're actually all integrated with Fairyring. So it's not too far off on like the transaction flow, but it is still off. You wouldn't just be pulling these random variables out of the encryptor tool or whatever. You'd be using Fairyport and communicating with Fairyring. But again, moving along with this tutorial, we then have the bid value, the public key, the random IBE ID, right? And then thus we get an encrypted value. Moving along there, we then prepare the bid data, and then using the classic, cast commands from Forge, we then call within the Solidity contract that has been deployed the submit encrypted bid with the respective variables populated from the private key 1. Sweet. And from there, they use those echoes to check like the block numbers to make sure everything looks good. Essentially, the second bid is then created and converted and submitted as well. I forgot to mention as well that the bid data is converted to an array just for the Solidity contract inputs. And then we finally are onto the derivation. So in terms of the derivation for the decryption key, you can see here that it is generated using the key share and using the share generator. And again, this would be obtained from Fairyring using Fairyport in actual application. And from there, the decryption key is used to decrypt by eventually, getting the format needed. So secret key is needed, converting to an array, again, using the same Python script from before that we're using to just convert to arrays. And essentially that decryption key or secret key is used in this command here, where we're actually interacting with the decryptor contract and calling reveal bids and passing along the respective decryption key. So you can see that here, if we on the left-hand side, the reveal bids, it's asking for the decryption key in this format. So it passes it along, and then that is used to actually call decryptor contract.decrypt and actually decrypt the variables and get variable amounts that are understandable and then assign the appropriate highest bid and end the auction. Cool. And finally, we then output the end results, which then we can just touch on down here. So down here on the terminal, we can see a lot of different echo and console logging. So let's see here. So yeah, from the initial deployment of the decryptor, that's there. And then you can see here the contract is deployed at address this. So that's where the actual sealed bid auction contract is deployed on the Arbitrum Sepolia test network. And then it submits the encrypted bid from user 1. Here's all the details for that. Once it's submitted, it's submitted, there you go. And then we then move along and submit the user 2. And as mentioned, then the key share is obtained, formatted, and then the revealing starts to occur, and boom, we actually have the highest bid be correct. So it's 150, and the highest bidder being the corresponding address. As mentioned before, the issues of refunds and transference of like fees and everything else is just out of scope for this video. And from there, that's basically the rundown of everything with this tutorial. So by the end of it here, right, the idea is that you have now seen the decryptor contracts deployed using Stylus, and being done so via bash scripts showing how to deploy them accordingly. And then you've seen an example smart contract as in the form of a sealed bid auction with Solidity deployed and interacting with the decryptor contract, showing the functionalities of Fairblock Tech with the Fairyring V1 network and Arbitrum Sepolia test network. And from there, you can basically take that and use that for reference as you create your own integrations, your own smart contracts to interact with the decryptor contract decryptor contract on one of these networks as well. So with all that, we'd love to see you clone this repo, fork it, or whatever, and make it your own. We'd be really stoked to see what others can build integrating with Fairyport and Decrypter using Stylus. All right, so back to the slides. So we can see here, now that we've done all this code walkthrough, we can see the functionality of it all working. What's next, right? Well, you see now that with Fairblock, safer apps can be built. There's already so much risk out there in crypto, so why risk it more without Fairblock? So here are some simple next steps depending on what you're looking for. So for folks integrating Fairblock, check out our docs, our Discord, and reach out to the Fairblock core contributors. And If you want to explore the code even more, I just kind of like laid out, some simple instructions. I mean, you know how to look at code. But yeah, I would recommend opening up two side windows, digging into it more, talking on the Discord. Happy to help. I'll be there. And then finally, if you're a community contributor, then simply we'll be setting up a repo for general integration issues or to help improve the processes. We'll share that link in the Discord as well soon. And with that, I would like to thank you so much for watching. I hope you've seen the power of Fairblock in action and are excited to build with it. Feel free to reach out to me on Discord or Twitter at #Titan, and I'll catch you next time. See ya. Oh, and my bad. This tutorial has now become 45 minutes or so. But it's been a great time. And now just go touch some grass, Anon, and we'll talk later.